So all we've basically done is product and quotient with power rule. That was it. If it was anything more than that, we couldn't do it. We need to know chain rule in order to do anything more than that. So with chain rule, it's whenever you're given something that isn't a straight up power rule. So for example, we're going to do derive number 1. Y equals x squared plus 3x, which is what we would normally have before. But it's going to be all cubed. All cubed. X squared plus 3x all cubed. So that we can't do straight up power rule because we actually have something cubed, correct? It's like we have 3 of those. So you have to like spread them all out and then do product rule. That'd be terrible. So I think that could be worse when you think about chain rule being bad. Okay. Y prime. For chain rule, all you do is you work yourself from the outside in. So we treat it as if it was like an x cubed. If it was like an x cubed, we drop the 3 in front, rewrite the x to the 2, correct? So that's what we're going to do here. We're going to go drop the 3 in front, rewrite the inside to the 2. Okay? And then we get chains behind it of things we haven't done the derivative of yet. So we're going to get a chain, a bracket behind it for the derivative of the inside. So what's the derivative of x squared plus 3x? 2x plus 3. Done.
We already said it.
That's it.
That's it?
That's it.
So that's all you do for the chain rule, right?
Yes. You might have a chain rule embedded in a product rule, though. So.
That's all I gotta do. Wow. What?
All right. 2. Ready? Okay. Quiet, please. F of x, guys. Stop. F of x equals the square root of x cubed plus 3x squared to the 2.
Easy.
It's supposed to be the 5.
Oh, you can't change it after we started.
Take backs. So whenever we're given a radical, our very first thing we're going to do is change it to a rational exponent. Okay.
Oh, I missed the square. Okay.
So we're going to get it to the 5 halves, correct? Then we can take the derivative of it. So we get f prime of x equals 5 halves x cubed plus 3x squared. Then I have to take 1 off of that. So I basically have to take off a 2 out of 2, right? So I'm left with 3 over 2. And then I have to follow behind with 3x squared plus 6x. The catch is that the 3x squared plus 6x, I can take a 3x out of it, so I still will. So we get 5 over 2, x cubed plus 3x squared, and 3 halves. Then we take a 3x out, and we're left with x plus 2. And so we get 15x all over 2, x plus 2, x cubed plus 3x squared. 3 over 2. It's just the wind. The wind makes the door rattle. There's no one there. Okay.
Does it matter if you change how you overrule the...
All right.
So you got the right thing, right?
Yes.
Okay, so the other chain rule we have to talk about is when we get a numerical base to a variable exponent. So we have these ones. where they're just like a binomial or a trinomial or something to an exponent. We have to use chain rule for that. The other reason when we have to is when we have a numerical base to a variable exponent. So for example, y equals 4x squared. Everything we've done so far has been a numerical base to a variable exponent, and we just did power rule, correct? This one is a numerical base to a variable exponent. You have to do chain rule to do these. Now, how you do the chain rule for them is, this is when it's numerical base to a variable exponent. So, the first step for these is rewrite it. So your one chain is to rewrite it. Please stop talking. So here's our rewrite. That is always our first step. Our second chain is ln the base. Ln is log base e. So we're going to ln 4. And it's just going to stay that way. It doesn't get any prettier. You don't turn to a decimal. So we ln the base. ln. So we rewrite it, then we ln the base, and then we do the derivative of the exponent every time. So what are we going to get as our third chain? Derivative of x squared. 2x. Done. So whenever you have a numerical base to a variable exponent, you will get 3 chains. You rewrite it, ln the base, derivative of the exponent. Sometimes some of the chains go away because they are the answer to them is 1. Right, Ben?
Yeah.
Yeah, totally. Okay, 4. What if I give you y equals e to the x, which we talked about yesterday, or f of x equals e to the x? And I told you don't worry about it, it's just e to the x, was what I told you for now. But let's see why it is. People forget and they think the e is a variable. The e is not a variable. E is like pi. It's a non-terminating, non-repeating decimal. E is 2.7181, blah, 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 blah. Okay? So e is actually a number. So it's like 4 to the x, e to the x. That's the same thing, because e is a number, just like pi to the x would be a numerical base to a variable exponent. So if we go to do the derivative of it, our first step is to rewrite it. Ln the base. And then derivative of the exponent, which is 1. Now let's talk about this. Ln e. Ln of e is the same as, ln is log base e. That's what it's a common log that gets used, just like log base 10 is just log because it's a common log that gets used. Ln is log base e. So if I go log base e, which is what ln is, of e, what does that equal? 1. We learned that in 30-1, correct? So ln of e is 1. So this becomes a 1 as well. So e to the x times 1 is just e to the x. So e to the x is the special one that doesn't change. Okay? So it would just be e to the x. 5. Y equals e to the 3x squared. So my y prime would be numerical base to variable exponent. No one should be on their phones. Numerical base to variable exponent. What is our first step? Rewrite it. What's our second step? Ln of the base. What's the base? E. And then what follows behind it? 6x, the derivative of the exponent. The catch with ln e is it cancels. So my derivative is just e to the 3x squared 6x. Or you could list the 6x first. Because chain rule is multiplication, right? Those chains that are touching each other is multiplication. If I wrote it this way, it would be equally the same. The last thing I want to go over before we start doing product rule with these is what if I give you a numeric coefficient? So say I give you g of x equals 3e to the 6x. So I'm going to put your pencils down because I'm going to show you why this works the way it does. So whenever we have a number in front of any of these, like a 3 or a 5 or whatever, the number just sits and you take the derivative of the back part. But why? Well, let's see why. Because if I do product rule with this, if I treat this like it's actually multiplying, which would be f, and this would be g, if I treat it like that, I told you that you have product rule when you have two variables that are being multiplied, correct? Technically, we don't have two variables, we just have a coefficient. But I want to show you if you did do product rule on these, you could. So we would get g prime of x equals g, which is e to the 6x, times f prime. What is f prime? 0. So that one just goes away, correct? Plus f, which is just the coefficient, and g prime would be just the derivative of this. So do you see how this half always goes away every single time? And really what you're left with is this number times the derivative of the back. So that's why that coefficient doesn't do anything. Even if you do product rule, it crushes the first part. So we get 3 e to the 6x ln x, or ln e, sorry, times 6. That cancels. So then that 6 would join the 3 and I would get 18 e to the 6x. So whenever you're given a coefficient on an e to the whatever, that number just sits and I take the derivative of the back. Okay? So, try 7. You pick your pencil up. Go. We're going to get y prime equals negative 44. Rewrite it, e to the negative 12x cubed times ln of e times negative 36 x squared. The negative 36 and the negative 44 join, and what do they get? What? Guys? E to the negative 12x cubed. So do you see why that coefficient just sits there? It's because when you do product rule, it cancels that one off anyways. Yeah. I dropped it off like a dork. I don't know what you're talking about. It's been there the whole time. It can be there. It can be behind the 1584. It could be at the back in a chain. It doesn't matter. It's all multiplied.
I got that.
The 36 and the 44 went together. I just threw the x squared in the front, but you can put it behind the number too.
Oh, you put the x squared in front?
Yeah, because I forgot it.
You would get the same answer.
All right. So that's the basic chain rule. They're not often just basic chain rule by themselves. They're often in a product rule or a quotient rule. So, 8. Y equals 6x squared minus 4x to the 2 times 3x cubed minus 5x squared to the 3. So it's going to be a product rule. So I want you to just set the product rule up. Okay? And then stop. So we have F, we have G, F prime. So this is the catch. Everyone's paying attention? Because if you get these, the unit's really easy. So when your F prime or your G prime or both of them use chain rule to solve them out, when one or the other does, your next step after filling it in is going to be GCFing, taking out things, because your F prime and G prime are going to have common terms with your F and your G. So whenever you take chain rules, you're going to be having common terms with them. So this is what's going to happen. So we're going to watch it. So we're going to get 2 to the 6x squared minus 4x, and I write it to the 1 so that I remind myself to not try and simplify that. Okay? And then I do the derivative of that behind, which is 12x minus 4. And if I want to simplify this, I can, but I never simplify the bracket with the chain rule, because look, F has 2 of those, and then F prime will have 1 of those. So I'll be able to take 1 out. So I don't want to simplify that bracket, even if it's to the 1. I don't want to simplify it. So that each of my 2 terms has 1 of those in common. So I can simplify this 12x, but I do not want to simplify that. So I'm going to leave it as 2. I'm not touching this. I'm going to keep writing it to the 1. I know it seems stupid, but trust me. And then I'm going to take a 4 out, and then it's going to be 3x minus 1. That 4 and that 2 can join, and they can become an 8. And then we can have 3x minus 1 beside it. And then we're going to have 6x squared minus 4x to the 1. And I'm going to leave it like that. Okay? So I literally just took the 4 out of the 12 and the 4, brought it to the front, made it an 8, and then rewrote the stuff. So I have F prime. Does everyone see how I got F prime? Okay. And the reason why I let you do it ahead of time is because people will reduce the 6x squared minus 4x, and I need you guys to not do that.
So don't take a GCF out of that one?
Do not. Because if you look, F has this squared, then F prime, which is going to be in the other term, is going to have that to the 1. So I'll be able to take 1 out of both of them. So I don't want to reduce the chain rule ones. Okay, even if it's to the 1. More often than not, it's to like the 3 or the 4, and then you won't do it. But if it's to the 1, I still don't want you to do it. Okay? Then G prime is going to be 3, rewrite it, 3x cubed minus 5x squared to the 2, which I can't take anything out of this because it's to the 2, okay, which means I have 2 of those. And then I'm going to follow behind with the derivative, which is 9x squared minus 10x. And then out of this bracket, I can take an x. I'm not going to ever take anything out of this chain ruled one. So I'm going to get 3. This is going to stay. And then I'm going to take an x out and be left with 9x minus 10. And then what I often do is I rewrite it with the chain rule at the back and then put all the rest of the stuff at the front. Just personal preference. So I'm going to go 3x, 9x minus 10, and then the chain rule bracket. Okay? Does everyone see how I got the F prime and the G prime and how I set those up? Because it does matter. Yeah? Okay. Now we're going to do product rule. Product rule, when you're done, gets you 2 terms. GF prime is 1 term, plus FG prime is the second term, right? Plus signs connect terms. So every single time you do product rule, you get 2 terms. So Y prime equals G F prime, and often people will turn their pages sideways when they do these. Plus F G prime. So maybe I'm going to erase my G prime. So when I do chain rule questions, I turn my page sideways. Okay, 1 term, 2 terms. Do you see that? And whenever you do the product rule, you will always get 2 terms, unless one cancels off like a 0 or something. But you get 2 terms.
I can't even write the whole thing on my page. I'm doing numbers stuff.
Yeah. All right. So we have to ask ourselves, what can I take out of the two terms? So I look at the coefficient numbers first and the variables first that are just kind of singular by themselves. So I have an 8 in the first term, and in the second term I have a 3x. So I look at those monomial terms, right? 8 and 3x. Can I take anything out of 8 and 3x? No. So the monomial terms are a no-go. Nothing I can take out. Then I look at my chain rule ones. So y prime. I look at the first term. I have 3x cubed minus 5x squared to the 3. And the second one, I have 3x cubed minus 5x squared to the 2. How many can I take out of both? 2. I can't take out 3 out of both because I only have 2 in the one, right? So in the front, I'm going to put one of my GCFs. I'm going to put 3x cubed minus 5x squared to the 2. Okay? What else can I take out of both? That's 6x squared minus 4x to the 1. Do you see why I didn't take that and take anything out of it? Because they match in both. So I'm going to take a 6x squared minus 4x to the 1. And then I think that's all I can take out. So then I write what's left over in my square bracket. Okay? So I took out 2 out of 3 of these, so I'm still left with 1. 3x cubed minus 5x squared. I didn't do anything with the 8 or the 3x minus 1, so they're staying. The 6x squared minus 4x to the 1 I took out, so that's gone. Plus. Then I look at my second term. I'm still left with the 3x. I'm still left with the 9x minus 10. This 6x squared minus 4x squared, I took out one of them, so I'm left with 1. And then the 3x cubed minus 5x squared to the 2, I took it all out, right? So I'm just left with that. So when we do chain rule, product rules, the first step is to do product rule. The second step is to take out GCFs, okay? Your third step is to take these brackets, and now you're going to actually have to expand that and then collect like terms of anything in those square brackets. I know, a joy. So we're going to go y prime equals 3x cubed minus 5x squared, 6x squared minus 4x. And then myself personally, I'll distribute the monomial into something first to make it a binomial, and then I'll FOIL them in the next step. Okay? So I'm going to go 3x cubed minus 5x squared times 24x minus 8, then a plus sign. Then once again, I'm going to put the monomial into one of the binomials. So I'm going to get 3x times 9x is 27x squared. 3x times negative 10 is negative 30x. 6x squared minus 4x. And then I'm going to have to FOIL it. Distribute those. So I'm going to get y prime equals 3x cubed minus 5x squared 6x squared minus 4x. And then I'm going to get a lot of fun. 3 times 24 is what? 72. X to the 3 times x. X to the 4. Then 3 times negative 8 is negative 24 x cubed. Negative 5 times 24, negative 120. X to the 3. And then negative 5x squared times negative 8 is positive 40 x squared. Plus, now this is where my brain is going to start helping. 27 times 6. 24s are easy because you just take 1 off each time. Multiply by 25. It's going to be 150, 162, 64, 164, 162, oh, that's right. 162, x to the 4, 27 times negative 4, negative 100 and what? X to the 3, negative 30 times 6 is negative 180 x cubed. Negative 30 times negative 4 is positive 120 x squared. And then we need to collect like terms. Y prime equals 3x cubed minus 5x squared squared. 6x squared minus 4x. Now, this is going to be fun. 72x to the 4 plus 162x to the 4. I think are the only ones. 100 or 234 x to the 4 minus 24x cubed minus 120x cubed is minus 144x cubed minus 244x cubed minus 252x cubed. Oh gosh, my brain. 252, 352, 432 negative. What do we get? My brain just forgot what I just said. Look, I said it, but now I can't remember what I said. Negative 432 x cubed. Oh, this one's nice. 160 x squared. And guys, if we can take something out, we do.
There's no room to make things out. You can't.
Well, you can. We're going to take it out in the next step. What can you take? Well, I know you can take a 2 out at minimum. Can we take something bigger?
Wait, you get rid of
Can we take a 4 out?
4x. I got a 12. I don't think we should go.
Can't take out a 4. You can only take out a 2. Gets to 117. Okay, so we take out a 2x squared. Then this rewrites. Then this rewrites. And then this becomes 117x squared minus 216x plus 80. Oh, I can put on my calculator first. Fun, right? Great time. Only you're invited. It's fantastic. Yeah.
That's it?
Yeah, that's it. Yeah. Okay, you're going to grab a sheet of paper out, another one. You might want to do this one in landscape, not portrait. Hamburger. I don't know how to say it, but they can get a bit difficult or difficult if I give you something like a half or together. No, the only way it'll be harder is instead of it being to the power of 2, I can make it to the power of half. And you guys are taking out fractions. You get 3 terms, you have 2 logarithmic differentiation, something totally different. All right. Okay, I don't remember what my number was. 8. 9. You guys trying this one on your own. F of x equals all right, so f prime of x mean f of x, sorry, f prime, wow, struggle is real. F, G. F prime is 4, bracket, 6x cubed plus 2x to the 3, please be quiet. And then I get 18x plus 2, which I can reduce that to make the 2 join the 4, make it an 8. And then do 9x plus 1. And then do 6x cubed plus 2x to the 3. And I don't touch that. Okay, G prime equals 3, 2x squared minus x to the 2. And then derivative of 2x squared minus x is 4x minus 1. Because it gets 6x. Okay, so f prime of x equals g f prime, which contains the 6x thing. Plus f g prime. Term 1, term 2. Remember, I'm literally just kind of doing polynomial chain rule right now, right? In university, they do chain rule all at once. All of it. Squares, halves, everything. About 6 examples, and then you should know everything. I'm blessed with it. All right. So I have an 8, I have a 3. I can't do anything with that. I have a 9x plus 1 and 4x minus 1. Can't do anything with that. I can take a 2x squared minus x to the 2 out, and I can take a 6x cubed plus 2x squared to the 3 out. 2x, sorry, to the 3 out, not squared. Then I'm left with 8. I'm going to be lazy, so I'm going to do these all together. I'm going to be left with 72x plus 8. And then I took 3 of those out, and I took 2 out of this one, so I'm left with 2x squared minus x. Plus 12x minus 3, and I took both those 2 out and 1 and 3 of those, so I'm left with 1. Then I have to distribute. So I'm going to get 2x squared minus x squared, 6x cubed plus 2x to the 3. And then I'm left with 72x times 2x squared is 144x cubed. 72x minus x is negative 72x squared plus 16x squared minus 8x plus 12 times 6 is 72. Thanks for the answer. X to the 4 plus 12 times 2 is 24x to the what? Squared minus 18x cubed minus 6x. Okay. You're going to help me put them together so we can go quicker. So we're going to get 2x squared minus x all squared, 6x cubed plus 2x cubed. So we're going to end up with, in brackets, 72x to the 4. What's 144 minus 18x cubed?
108.
That is not even close. Why did I write that?
216. 216.
I was like,
yeah, 216.
I wonder what.
That's like, I think.
144x. I want to get off the stage. Why is this cubed? Why did I? This is what, guys, long time ago, when you didn't comment, this was supposed to be 18x squared, then this was supposed to be squared, then this was supposed to be. Remember when we had this conversation as friends? Thanks, friends, or lack thereof. All right, so this is a squared, and then this is a 4. No, you guys are supposed to correct me like way the heck up there. 4. What else is messed up now? This should be a 3. And then that's fine, and that's fine. Okay, let's try again. Bueller. Oh, tiniest eraser known to man. Can't even hide that I'm erasing. It's just so slow. Okay. 144 plus 72 is not 108. Either way, whatever the heck that was. 216 x to the 4. Negative 72x cubed. Whoa, this was. Sorry? Negative 90x cubed. Guys? 16x squared, 24x squared is what? And then negative 8, negative 6. What can I take out of that? 2x. So I'm left with 2x squared minus x squared, 6x cubed plus 2x to the 3. Okay. 216 divided by 2 is? There's a 108. That's actually true. 90 divided by 2? X to the 40 divided by 2? 14 divided by 2?
7.
And now for punishment, because you didn't do that, I was going to give you another one of these, but I'm going to give you one with a half before tomorrow. Let's see it out. 10.
I will. No.